Good afternoon, Stereo Police. Out here working on the 73. Got a minor issue with the fan, the blower fan. Replaced the heater core, that's working good. And then at some point when it got cold out, the blower fan, which has off, low, and high, basically two settings, it doesn't work. It just stopped working. Let's do a cold start. And I mean, this is a cold start. This truck hasn't started for over a week, and it's a chilly day. I'm going to give it 4 pumps. Not bad. Not bad at all. That's surprising. Thought it was going to give me a little, the roughies. No blower. All right. So what to do first? Let me shut this door. I got a little time today. I need that fan working because I'm going to be driving this car in the winter, this truck in the winter time. And it's a cold truck to begin with, but man, I'll tell you what, I need that heat. So let me try to hatch out a schematic diagram of what I think. Because this is, you know, an old school truck. Things are pretty simple in terms of how they operate. There's no modules, no computers. Everything is straight wired. I do not have a manual for this truck. So I'm going to guess. I'm going to take a guess. Okay? I'm going to draw a battery, and that's going to be the car battery right there. And then I'm going to draw a fuse. Let's see if there's a blower fuse in here. Now there's one for the heater and the AC. Is that one? Yeah, it's a good fuse. Nothing wrong with that fuse. Alright. I'm going to take a voltage read off it anyway. So there's a fuse, which is a 20 amp. There's no AC in the car. I'm going to guess. From there we go to the switch, which is right there. So that switch has an off position, low, and high. Alright. Now over here we're going to have the blower motor. That's the motor that is not working. It's pumping out, that's pushing the air through the heater core. And in the heater box, the blower motor is going to have a ground somewhere. And then it's going to have a positive lead. Now in the heater box, I'm guessing that when high is selected, we just go right to the motor, 12 volts. And when low is selected, we go through a resistor. And that resistor is normally inside the heater box, because that resistor is producing heat, you know, as it's dissipating. Some of that, it's reducing the voltage from, you're going to have 12 volts here and 12 volts there, and you will have 12 volts here, but on this side of the resistor you'll have something less than 12 volts, let's say 6 volts, depending on the resistance of this, so that the motor runs slower on low. So this is going to dissipate heat to burn off that, to drop that 6 volts. So the question is, where do you start the troubleshooting? And what I think I will do, I can't get on my back and look up over here because it makes me dizzy. I have a little bit of a positional vertigo. So in order to access this switch, hang on. In order to access that switch, I'm going to have to pull off this guy here, maybe even pull the radio out. But before I do that, let me make sure I got 12 volts on that fuse. 12 volts on the fuse. And I do have easy access, I believe, where I know where the resistor is. I know where these two terminals are right here. I can pull that glove box liner or even go up from below and access them. So that would make more sense to start out, number one, making sure, step one, make sure that we have 12 volts here. It's going to be step one. And step two is come over here and see if we're getting anything. To see if we're getting 12 volts. Step two. If we're not getting 12 volts on the fuse, then I don't even need to concern myself with what's over here. I'm going to go right to the switch and find out if the switch is bad. I'm sorry, I backtrack. If we're not getting 12 volts here, then it's something here. The fuse, even though it visually looks good, the fuse is bad, or there's something prior to the fuse in the wiring. If we are getting 12 volts here, then I will go ahead and measure over here. If we're not getting 12 volts here, or 12 volts there, then it's somewhere between there and there, either in the wiring, or it could be a bad switch. There's the troubleshooting right there. All right. So like I said, I got about an hour today to deal with this. Let's see what we come up with. I have other options too, but let's go with that first. And the truck is warming up. Let's let it continue to warm up. Emergency brake, or the parking brake is on. Good. All right, be right back. I need to go get my digital voltmeter. All right, remember the truck is running, so the alternator is charging. It's going to be more than 12 volts. Alternator's charged somewhere between 13.5 to 14.5 volts. So I've got the negative probe of the voltmeter grounded, and I've got the positive probe here, and we're now going to touch the heater we are getting 14 volts, which is what we'd expect. So we are getting 14 volts. Now I'm going to need, I'm going to need to pull this glove box liner out. Let's see if I can do this without, see if I can do this the easy way. There's these little pins in here. It's a pain in the butt to get those out. Yeah, I'm going to need to get a, let's see if I can do it by hand. Nope. Come on out, you little puppy. Alright, I need to get a tool. Alright. Glove box liner is out. See this wire right here? These are the two wires. These are coming from the switch. And I believe it's those two right there. And then the one wire that goes to the motor comes out of the heater box. And I believe it's that green one right there. Okay. So, let's go ahead and remove, wiggle these two off. And take a voltage measurement. Let me set that up. Be sure. There's our 14. Let's go into the red side. Nothing in there. Let's go into the black side. Oh my. Got 14 volts coming from the black wire. Oh my. And we're on high. Now let's keep this on the black wire and turn it to low. And I bet you that voltage will switch to the red wire. I'm doing this with one hand. Okay. I just switched that switch to low. The 14 volts went away. I'm still probing the black wire. Now let's probe the red wire. And the 14 volts went to the red wire. So the switch is working. That's why when I touched, that's why the blow, I think we got a bad blower. Alright, and then let's go ahead and test that green one again. Let's get nothing on that. Hold on. Okay. We're now probing the green one. Nothing on that. It's my theory that, let me pull that out. Okay, we're on to something now. Switch. Okay, we're on to something. Something big. It's going to be the blower probably. So here's what we did. This is the fun of troubleshooting. Here's what we did, and we got one more step to go. We turned this switch, well, we verified the fuse, then we turned this switch to low, and we got our 12 volts there. We turned the switch to high, we got 12 volts here, nothing there. Then we turned the switch to low, we got 12 volts there, nothing there. That's our connector that you just saw with the red and black wires. I also directly shorted with alligator clips, directly shorted from here to there, and from here over to there, the blower wouldn't work. Didn't have any fan action. Now that green wire, I think, is this one here, but there's a little output from it right there that we can probe after we hook that connector back. So let's go ahead and hook this red and blue wire connector back on, and down there on that guy, we're going to leave it exposed. We're going to hook an alligator on it. I'm going to turn the fan off right now so I don't short anything while I'm doing this. All right. Okay, there's our alligator. Then I'm going to hook the positive probe. Hook the positive probe up and let it dangle so it doesn't touch anything. Okay, so we're now probing right there after the resistor. So we'll probably see two different, well, no, we won't, because there might not be any current flowing. But right now we're seeing 0 voltage because the fan switch is off. Let's turn the fan switch to low. We now see 14 volts because what's happening is this switch is on low. We're going from there to there. We're not seeing a lower voltage because there's no current flowing through that motor. That motor has an open circuit somewhere, or it's in the wire. Now, when we go to high, right here, we should also see 12 volts right there at that node. Let's go to high. Yep, we got it. 13.7, but it's all the same. So everything from here on over to there is working. From here down to there, we got an issue. And from here down to there, we're dealing with the blower motor. Let's open that hood and see if we can, I don't know how that green wire connects to the motor, but let's see if we see anything under the hood. I'm going to go ahead and turn the car off, pull the keys out. Let me hit stop for a second. Okay. Nah, I don't need any help, buddy. Here's the blower motor right there. Right there. You can see there's 2 wires going into it. One of the 2 comes through the firewall. Right there, and you can see it's the green wire. It becomes kind of blackish from time. But that's the green wire we were just toying with. I don't see any breaks or kinks in it. It comes down here directly into the blower motor. The other wire from the blower motor goes up over there and attaches right there to ground. I don't think I'm showing you that. Hold on. There it is. It's attaching to ground right there. Could it be a bad ground? Yes. So I'm going to, the first thing I'm going to do is just go get a screwdriver and wiggle that ground connection right there. Take a look. I think I'll just pull that off and brush it a little bit and put it back on. It could be a bad ground. If that's not it, then we got ourselves a bad blower motor. Yep. Diagnosed. All right, let me go ahead and remove that ground connection first. See how, so we're going to take care of that right there, that ground first. And if that doesn't do it, I could, under the hood, clip this wire right here, which I'll do, and check for the voltage to make sure it's getting there, but I'm sure it is. I think the next step will be to pull the blower motor out. I don't think that's going to be a big deal. I'm not going to do it today. I just wanted to do the diagnostics today. Okay, go check that ground first. I'll show you what it looks like. All right, I've got the connectors back on. Got the ground wire hook taken off. That was a bear to get off. The ground wire to the blower motor. I've got an alligator on it. I've run that alligator right over here. I've wiggled them around to bite into the body. It's going to a known grounded surface. Going to go ahead and I'm not going to start the truck. Just going to nothing. All right, I'm going to do one more thing to fully confirm it's the blower motor. I think it's the responsible thing to do, even though it takes a little extra work. I'm going to confirm with a continuity tester. Number one, we truly have a ground here. And then I'm going to confirm that we do have 12 volts truly getting all the way down to the blower motor. Going to have to cut a wire for that. Let's start with continuity to make sure we truly have a ground. I need to take a break for a second. My hands are getting cold. Got to go inside and warm them up. Be right back. Of course, to you, it's going to be instant. Okay. We're on continuity beeper. On resistance measurement, continuity beeper. You see the little speaker there. I got one side of my meter hooked up directly to battery negative. Let's take the other probe and start touching things that might be grounded like that. And then here is the yellow wire that goes to the green wire that goes to our ground up there. And we are getting continuity to ground. And then let's see if I can reach, make sure we got ground all. Gotta pull that meter towards me a little bit. See if I can reach. Yeah. So we're getting ground. We're definitely getting ground to the motor. So the next question is, are we getting 12 volts all the way down to the motor? I'm gonna have to clip this and splice it and measure it. I wonder if I do a couple whacks with a hammer, if that thing will start up. I mean, you know, you might laugh, but, you know, motors are funny that way. We go ahead and, I'll go ahead just to try it. Go ahead and turn on the fan. I mean, it's, okay. Fan's on high. Of course, nothing's happening. Everything's hooked up on the inside. I'll take the end of the screwdriver here. Ah, it's working. Listen. It's working now. You can hear it. It's blowing. Well, I don't need to measure the voltage now. All right. See? For those of you who laughed. Yep. It's blowing. It's definitely sucking air in. Let's go ahead and start the car. It's probably not going that well. This is too thin of a wire for ground right here. You know what? It'll probably be more efficient when I hook that ground wire back up, because this thin alligator wire is actually adding resistance in line with ground. Let me turn everything off and get that ground back hooked up, because it's not that powerful of a blow right now for high. All right. Get the ground up again. Couple whacks with the hammer. Knock some sense into it. All right, got the ground hooked up. Let's take a look. Everything's hooked up. Ignore that thing. That thing sticking out right there. Ignore that. Okay, everything's hooked up. Back to normal. Let's turn on the fan and see if it blows as fast as it should. Oh, wow. Ah, that's good. That's really good. That's at 12 volts. Let's see if it blows at 14. See if I can show you with a towel. Yeah. I mean, this is a full towel, but there you go. It's blowing good. Okay, low. Can't really hear it, but it's blowing. It's blowing low. High. Off. Low. High. Wow. Well, I still think if that's what it took to get it running, still think a new blower motor is going to be in order. But at least we got to the bottom of it, and that's how you diagnose it. Nothing wrong with a couple whacks with a screwdriver or a hammer, especially when it comes to turning mechanisms with bearings. I think what that's an indication of is ultimate bearing failure. In other words, power is getting to the motor stators and you know, the electronics of it, but there's not enough starting torque to overcome the bearing friction. And when you give it a whack, that helps overcome the bearing friction. Now, whether or not that motor has ball bearings or sleeve bearings, most likely sleeve bearings, I don't know. But at least I know how to get that motor running until I buy a new motor, a new blower motor. So, all right. Working like a champ right now. You know, once you overcome the initial friction of what might be bearings going bad, or maybe it was just a little crud in there. Maybe it's cleared itself out now. What do you think? Maybe I ought to give it a little time. Maybe the crud is gone and maybe it'll work. I don't know. I know this. It only started when it got cold. There's expansion and contraction. Maybe that, you know, I'm just speculating. We're getting nice and warm now. All right. Well, hope you enjoyed that. We're running good now. Truck is running good. shadow. You can see the shadow of the condensation. Watch. Look at the shadow. Wow. It's not smoke. This thing doesn't burn oil, nothing. It's tuned good. It's not soot from a rich mixture. None of that. It's just condensation on a cold day. I'll show you. You can see it. All right. Well, you know, I'll make a follow-up video if I decide to get a new blower motor, but I'm going to let it ride for a while. At least I know how to get it running. Lift the hood and whack on the damn thing. That's old school stereo police. Hope you enjoyed. Ciao.